6 tons of bone-crunching bad dreams. The undisputed king of the dinosaurs. There has never been a serious challenger to its crown until now. Tyrannosaurus Rex, king of the tyrant lizards, and its challenger, Giganotosaurus. The clash of the titans, 2 heavyweight prize fighters side by side for the first time. At the Philadelphia Academy of Natural Sciences, Peter Dodson supervises the weigh-in.
In the red corner, the champion from North America, Tyrannosaurus Rex, 40 feet in length, 10 feet high at the hips, 6 tons in weight, the tyrant lizard king. In the blue corner, the challenger from South America, making its first appearance in 100 million years, 41 feet in length, 10 feet in height, 7 tons in weight, Giganotosaurus, the giant reptile from the south.
2 killer dinosaurs. They lived millions of years apart, on 2 different continents, but they were the 2 greatest predators of all time. New discoveries are bringing them back to life. But which was the king of the killer dinosaurs? T-Rex specimens have been found only in North America, and only in the Hell Creek Formation dating back 65 million years. The Hell Creek runs from Alberta in Canada in the north to Denver, Colorado in the south. Evidence that T-Rex ever existed was discovered in 1900 by a legendary American fossil hunter. Named after a showman, Barnum Brown, a showman himself, had a nose for fossils. Sniffing about on a hunch in a section of the Hell Creek that runs through Montana, he uncovered the first 3 T-Rex ever found. Barnum Brown didn't like to get his fancy clothes dirty, so he hired a gang of workmen to dig for him.
It's bigger than anything I've ever seen. Came out right here. What we need to do is dig there, explore, see if there's anything there, because it's on this level.
Pickaxing for profit and not posterity, he and his men were often careless, their specimens incomplete. Still, the creature Brown sent back east was horrifying. A monster from hell, it inspired Henry Fairfield Osborn, curator of the American Museum, to name it Tyrannosaurus Rex, king of the tyrant lizards. At first, scientists thought it was a lumbering, sluggish brute, a scavenger. It was so massive, they thought it could barely move and lay about on the ground for most of the time. And when standing, it needed its tail as a third leg for balance and support. Barnum Brown's prize find, made in 1907, was only 45% complete. For decades after, specimens of T-Rex remained fragmentary and rare. Then, in 1990, an almost perfect specimen was found, 90% complete. It would dramatically change scientists' understanding of the Tyrant King. Neil Larson and his team from the Black Hills Institute have excavated more T-Rexes than anyone else.
The area around here is extremely rich in fossils. Since 1992, we have excavated 3 Tyrannosaurus Rexes. One by the name of Duffy, about a quarter of a mile over this way. one by the name of Stephen, about a quarter of a mile over this way. And we brought Stan back to the place where he lay buried for nearly 65 million years. Tyrannosaurus rex has the most incredible bite and biting power of any dinosaur that has yet been found. He's got some 6 and 8 inch long teeth that poke out of the jaws. Now these teeth are shaped quite similar to a knife, but rather than being flat like a knife, they're shaped round like the end of this pick. This gives Tyrannosaurus rex the ability to not only just cut through meat, but also to be able to punch through bone.
In the crunching department, tests show that T-Rex had biting power nearly twice that of an alligator and about 3 times more than a lion.
That, along with these incredible muscles that extended all the way up to the top of his head on the inside, and muscles that extended inside of the lower jaws from there, muscles from the outside of the skull that extended down on the outside of the lower jaws. This, coupled with the teeth, made this dinosaur the most incredible biting and eating machine that has yet been found.
Another major discovery, less than 15 miles away, proves that far from sluggish, T-Rex was a fast and agile sprinter. It left these footprints as it raced along. Discovered by Mike Trebold, they are the first of their kind.
I was coming through this area for about the 3rd time this year when I saw this concretion before me. It looks just like a large T-Rex footprint. And I laughed to myself because this has never been found in the Hell Creek before. When I saw the one behind it, I thought I just might have discovered the very first T-Rex trackway.
The tracks are almost perfectly lined up, left foot in front of right. It shows that T-Rex had a well-developed sense of balance. A striding animal, like a bird, it placed one foot in front of the other, unlike the slow, sprawling waddle of most reptiles. Another exciting piece of evidence is the extension behind the heel of each print.
That extension is an impression of the back part of the leg, so it very possibly was crouching or stalking its prey. Probably hunched over slightly, very alert. It changed direction in this area, continued on, and speeded up its gait once again.
The trackway here is remarkable. Rather than impressions of the monster's feet, they look like actual feet because of the way they were formed. When T-Rex walked here, the ground was composed of soft clay covered with vegetation. As the monster stepped in the clay, it left footprints which were filled in by rotting vegetation, which over time were fossilized. When Trebold dug away the softer surrounding rock, the footprint is exposed. T-Rex's legs are 10 feet long. The proportions of its individual leg bones indicate how fast it could run. Like an ostrich, T-Rex had a long shin bone compared to the thigh, and long extensions to the flat of the feet. Calculations show that T-Rex could cruise at speeds of about 30 miles an hour. Its long tail was vital for balance. It provided stability in the same way a pole helps a high wire walker. Armed with its tail, T-Rex could maneuver through the forest at high speed.
I would think that an animal like this active and this large, could easily have done the 100-meter dash in 5 seconds. It was a very active, very fast animal, very alert.
But it wasn't just fast. It had eyes that could see in 3D.
Tyrannosaurus rex had enormous eyes. He had eyes about the size of this softball. And the eyes faced in the skull forward. This gave him binocular vision, like a predator. This allowed him to judge depth, to see distance, to even see color.
Like an eagle, T-Rex's eyes were designed to spot prey. Scientists now believe T-Rex was more eagle-eyed than an eagle. And to process information, T-Rex also had the largest brain of any dinosaur yet found.
We as humans have a brain nearly the size of a football, but Tyrannosaurus rex did not have all these wonderful features that we as humans have. If you take away all the storage that we have in our brain, things for memories and things that happen to us and things for calculating and wondering at the beauty of the world, Tyrannosaurus rex didn't have that.
The brain was the control center of this vicious killer's body, although its thoughts were very basic.
Tyrannosaurus rex basically thought about the same thing that a teenage boy thinks about on a Friday night. It thought about girls or the opposite sex. It thought about eating. It thought about sleeping. Thought about more eating again. And for Tyrannosaurus rex, if it got angry, it would get angry immediately.
Larson's skulls show evidence of savage face biting, especially with each other, the result of battles for food or a mate. T-Rex remained undisputed heavyweight champion of the world for nearly a century. But then, another brute with big teeth, a big appetite, and a bad attitude was found in Africa to challenge for its crown. There are few more inhospitable places to go dinosaur hunting than in the deserts of North Africa, where temperatures soar to 125 degrees Fahrenheit and more. But intrepid German paleontologists working in Egypt unearthed fragments of a giant meat-eater with massive shark-like teeth. They named it Carcharodontosaurus saharicus, shark-toothed reptile of the Sahara. But its remains were destroyed in the Second World War. After the war, French explorer René Lavocar spent months wandering alone in the inhospitable wastes of the Moroccan Sahara. He too found shark-like teeth. In 1995, Chicago paleontologist Paul Serino led another expedition into the heart of the Moroccan Sahara. He had little to go on other than Lavocar's now cold trail, and that the fragments had been found in rocks about 100 million years old. After 2 torturous months of searing heat, searching rock surfaces that tore their boots to shreds, their efforts seemed fruitless.
Yep.
Then, with only 2 days of the expedition left, Serino hit pay dirt.
It was totally unpredictable. I saw an area of outcrop. I walked towards it. And I walked over and I saw in front of me a pile of bones, fragments. I picked this thing up, looked at the upside down side, and my eyes popped out of my head. Here we had the back end of a theropod skull, beautifully preserved.
He went back to see if the bones might have fallen from higher on the sheer cliff.
I circled around again, and that's when I looked up, and I saw on a pillar of rock the rest of the brain case and the skull going into the side of this cliff. And it was a sheer cliff. And it was sort of like a little statue sitting up there. And again, this was too much. I mean,
Sure that holds the list. Look at this. Have you guys seen the teeth? This is incredible. 1, 2, 3. There's a replacing tooth here. 4, 5, 6, 7, 8, 9, 10, 11. We got the whole jaws.
On the count of 3. 1, 2, 3.
Serino had found a skull 5.5 feet long,
1, 2, 3.
with 6-inch shark-like teeth. Back home in Chicago, Serino slowly pieced together a skull even larger than the champ's T-Rex. Serino introduced a stockier, slower, heavier animal. A bruiser with a wrestler-like neck and a narrow skull. A brain half the volume of T-Rex's, and quite different teeth. While T-Rex chomped with round, puncturing teeth, its African rival used its sharp, slicing teeth to bite, rip, and tear. But Africa's shark-tooth killer was about to be outclassed by an even stronger shark-tooth challenger from South America. T-Rex was about to meet its match in Argentina. The ultimate challenger to T-Rex was trained in the vastness of Patagonia and was named Giganotosaurus, the giant reptile of the south. It comes from the same stable of fighters as its sparring partner, the shark-tooth killer from Africa. 150 million years ago, South America and Africa were still joined, and the ancestors of the two heavyweights were free to roam across the continents. Scientists had believed that South America split off from Africa about 130 million years ago. But these two shark-toothed challengers, both 95 million years old, were so closely related that scientists now believe that Africa and South America could only have split apart at about that time. At the Carmen Funes Museum in Patagonia, Rodolfo Coria is no stranger to the world of giants. He led the team that excavated Giganotosaurus. Today, they are setting out early, and with some excitement. They have found another giant. Argentina is fast becoming the Texas of the paleo world. Everything seems bigger there. When Coria and his team first unearthed Giganotosaurus, the fossil bones were huge. When they reached the end of its shin bone, they realized that it was not only the biggest meat eater known in South America, it was the biggest carnivore in the world.
It was really exciting because, you know, it doesn't happen every time to find the records in dinosaurs.
But the specimen Coria is excavating today is even bigger, establishing that their first find was not a freak. Like its African cousin, Giganotosaurus's teeth are distinctly different from the bone-crunching, rounder teeth of T-Rex.
The teeth are very sharp in the edges, but at the same time are very narrow. They look like shark teeth.
Giganotosaurus's eyesight was not as sharp as T-Rex. Its eyes were in the side of its head. As a hunter, it would be poor at judging distance, having to bob and weave its head up and down and side to side to pick out its prey against a background. Giganotosaurus hunted very large prey, plant-eating giants many times its own size. Ponderous, slow-moving prey. Just a few miles from Coria's discovery, fellow paleontologist Jorge Calvo is following in the footsteps of just such a victim. This is the rear foot of one of the giant plant-eaters that Giganotosaurus would have hunted. It is over 3 feet across and 10 feet around. It would have weighed at least as much as 5 elephants. This is only a mid-sized plant-eater, 80 feet long, named Rebeccasaurus. But Coria is even more excited by something he hadn't seen before. A Giganotosaurus track stalking its Rebeccasaurus prey. Some snack. 80 feet of plant-eating dinosaur, so long it could only fit into the museum by wrapping it around a corner. Giganotosaurus was a true heavyweight, a raging bull. It was trained to stop much larger prey. But in a title fight with T-Rex, the Tyrant King, who would be the ultimate victor? In the red corner, representing North America, champion killer of the prehistoric world, the Tyrant Lizard King. In the blue corner, the challenger from South America, Giganotosaurus, the giant reptile of the South. A pre-fight assessment from the experts.
The smart money's definitely on the reigning champion. He's got a brain size twice the size of his opponent's. He's able to think faster on his feet, check out his opponent's moves.
Paleontologist Ted Deichler has been following Giganotosaurus, the giant.
The truth is, the giant's a bit of an unknown quantity. Only one skeleton has ever been found, and no one's had a good look at him in a fight. But judging by the looks of him, I'd say he's a bruiser, a slugger.
T-Rex and Giganotosaurus evolved on different continents at different times and hunted different prey. Giganotosaurus took on animals several times his size, while T-Rex preyed on animals smaller than he was.
T-Rex likes to go in for a quick kill, rather like a lion does today. A slashing of jaws, a ripping of flesh, a crunching of bone.
The word is that the giant attacks his prey quickly and violently, and backs off to survey the damage. He may follow his prey like the Komodo dragon today, waiting for the animal to weaken and attacking again.
And like the Komodo dragon, the giant's mouth was a toxic breeding ground for virulent bacteria.
Judging by the bad breath, infection could be a problem after the bite.
Giganotosaurus would then return and finish off its weakened prey.
T-Rex's arms may look puny, but they're not. They're heavily muscled. I've seen him lift 450 pounds, one arm, in training. That's an Olympic record. He may be a ton or two lighter, but he's a super heavyweight. He's fast, he's agile, he's much more mobile than his competitor. He's got all the moves.
The giant's a bit longer than the Tyrant King, so he's got a better reach. He's also a bit heavier, so he may not be as fast or as maneuverable. But if he can sink those teeth into the champ, he'll rip him apart.
The challenger is bobbing and weaving. Is this to taunt the champ?
To get perspective, he has to bob up and down or move his head side to side.
T-Rex has a great advantage. His eyes face forward. He has three-dimensional vision. He can judge depth. He can make his moves perfectly.
That is, as long as T-Rex has got two eyes. If the giant can cut one of them early on, that advantage will count for nothing.
He's obviously not as bright as the champ. He's got a smaller brain. But that might be to his advantage. He'll be less sensitive to the pain. And his size will help him soak up the punishment anyway.
Look at those teeth. This is one of the most devastating sights in the history of life on Earth. These teeth are long, they're heavy, they're designed to pass right through flesh or bone. They give Rex the ability to bite any part of an opponent's body.
The giant has more specialized teeth. Lethal, sharp cutters. Steak knives. He'd avoid the bone and go directly for the flesh. And if the champ lets his guard down, one bite could do a lot of damage.
The clash of the titans. Two killer dinosaurs. They lived millions of years apart on two different continents. The two greatest predators of all time. Who won the rumble in the jungle? With its superior brain, eyesight, and agility, T-Rex would have made mincemeat out of his South American challenger. Today, T-Rex remains the undefeated heavyweight champ, king of the tyrant lizards.
This would have been one little creature. Jaws.
65 million years ago, an object from space hurtled toward planet Earth. 65 million years ago, an object from space hurtled toward planet Earth. 65 million years ago, an object from space hurtled toward planet Earth at 150,000 miles per hour. On impact, it triggered a disaster unlike any ever conceived by man. Could this gigantic collision have ended the reign of the largest creatures ever to walk the land? For the dinosaurs, it was a day just like any other. Huge plant-eating giants browsed in the forests hunting for food, while vicious predators stalked their prey. Little did they know that this day would be the beginning of the end. The countdown had already begun that would lead to their annihilation. For centuries, what killed the dinosaurs has mystified paleontologists. Was it a natural disaster? An earthquake, perhaps? A flood? Or a volcanic eruption? Whatever it was, it had to be so catastrophic that it affected the whole planet. 65 million years later, all that's left of the dinosaurs are footprints and their petrified remains. Near the ghost town of Ludlow in southeastern Colorado, fossil footprint expert Martin Lockley has made an amazing discovery that helps document the dinosaurs' doom. He has found a relic from the last generation of dinosaurs to have walked the planet.
Well, what we have here is a footprint, not the world's most beautiful footprint perhaps, but nevertheless a very important one. You can see, if you look closely, the outline of 3 toes, one here, the middle toe here, and then the other one would have been broken off here, and the heel goes around to the back. Now this is a fairly typical shape for a duck-billed dinosaur or a hadrosaur. If we measure this, it's about 24 inches, a couple of feet long, and the hip height of one of these dinosaurs is about 4 times the length of the footprint. We're looking at a hip height that's going to be about 8 feet.
This gentle plant eater couldn't have known it would leave its mark as one of the last dinosaurs on Earth.
This layer of rock here is the same layer that we found the hadrosaur footprint in over there. This whole sequence of rock here is extremely important and critical to the study of dinosaurs. This is a geological marker layer. It represents the end of the age of dinosaurs. So that footprint layer is only 14 inches below this. That probably only represents decades or at most centuries, not tens or hundreds of thousands or millions of years.
Geologists called this layer of rock the KT boundary, the moment between the Cretaceous period and the Tertiary 65 million years ago, when all the evidence of dinosaurs vanished. A major timeline in Earth history, the KT boundary can be seen sandwiched between layers of rock virtually around the world.
Everywhere we find the KT boundary, it's the same story. Below the boundary, lots of evidence of dinosaurs, tracks, bones, etc. But above, they appear to be gone, disappeared without a trace.
What could have killed all of these mighty beasts? To find out, scientists on the extinction trail are probing the KT boundary, though sometimes it's not that easy to get to.
We're
we're obviously stuck here and we can't get down here to the arroyo. So basically what we would like to do is to borrow his horse and go through this slop and actually move some of our equipment.
For geologist Dave Kring, the rocky outcrop of Membral in northeastern Mexico is worth the hardship. Here, where the KT boundary is clearly distinct, samples have produced the first vital clue to the death of the dinosaurs.
The rocks that I am standing on were deposited when dinosaurs existed. Right at this level in this rock, the dinosaurs disappeared, and above it is an incredibly fascinating sequence of rocks. It's very thick, much thicker than the KT boundary sediments found anywhere else in the world. And way at the top of this sequence, we've taken samples into the laboratory and we found a very special element called iridium.
Iridium is special because it's rare. When scientists analyzed rock samples taken from the KT boundary in Europe, they were astonished to find 1,000 times more iridium than usual. The same massive amount was also found in rock samples taken from other sites around the world. If iridium is so rare, then where did it come from? Following a hunch, Dave Kring checked out some unusual rocks in the Tucson Planetarium in Arizona.
Iridium is a very rare to almost non-existent element in rocks in the surface of the Earth. However, we found huge abundances of this element in rocks deposited right at the time when dinosaurs disappeared. The fascinating thing about the element iridium is it is constantly being rained down on us by cosmic debris.
These are no ordinary rocks. They are lumps of minerals, iron, and other elements that fall to Earth from outer space. Only objects from space contain large amounts of iridium. Something must have bombarded the Earth, then disintegrated, sending a cloud of iridium-laden dust around the world. But cosmic dust didn't kill the dinosaurs. So, what did? Space is infinite, but it's not empty. Planets, galaxies, and stars are swirling masses of dust pulled together by the forces of gravity. This uncharted mass is billions of miles across and contains zillions of chunks of rock. Speeding through this vastness are comets and meteors. Comets are mostly made of ice and dust. Meteors are mainly metallic objects. For centuries, the sight of one struck fear and awe. Most of them burn up in the atmosphere, but not all. The moon clearly shows the visible dents and scars of impacts from outer space. And, like the moon, the Earth has also been hit. Here, most craters are eroded away by millions of years of wind and rain, but some can still be seen quite clearly. The most impressive is Meteor Crater, near the town of Winslow, Arizona. To cosmologist Jay Malaj, the crater clearly shows what happens when big things, traveling very fast from outer space, hit the ground very hard.
This crater is 50,000 years old. Although it's a mile wide and 600 feet deep, it was created by a meteorite only about 150 feet across. An iron meteorite that struck the rocks on the surface here, traveling at about 150,000 miles per hour. It penetrated the rocks in only a wink of an eye, a tenth of a second, and deposited its energy, which blew this crater out in a matter of 10 seconds.
If this impact was so severe, then what kind of destruction could a much larger meteor do? There are giants circling the Earth even now. In 1995, Comet Hale-Bopp was seen for the first time. It's twice as long as Manhattan Island and more than 20 miles wide. Passing the Earth every 4,000 years, it's just one of hundreds of large comets and meteors that threaten our planet. If evidence of huge amounts of iridium proves that a meteor hit Earth 65 million years ago, how big was it? The amount of energy needed to create the devastation that would kill all the dinosaurs had to be gigantic. The problem has always been proof. If something really huge crashed into the Earth, then where was the crater? The first clue came unexpectedly in the Gulf of Mexico. While geologists like Luis Marin were surveying the Yucatan looking for oil deposits, an unusual round structure buried deep below the Earth's surface appeared on their maps.
They use different techniques. For example, they use a magnetometer, which is a cylindrical shaped instrument that is flown out of airplanes, and it allows one to cover large areas. They also drilled, both on land and at sea. In other words, they go down and bring back cores and examine them for the presence of oil and gas. They didn't find any oil. However, what they did find was this very strange looking circular anomaly in Yucatan.
This strange bowl-shaped structure was 150 miles across. When mapped, it revealed disturbances in the Earth's magnetic field, usually associated with ancient volcanic activity. But these rings are too uniform and too large to have been caused by a volcano. Luis Marin believes the rings are a smoking gun. The main square of the town of Chicxulub on the coast of the Yucatan Peninsula is situated right in the middle.
So here we are, right dead center in the middle of this circular structure, which is 75 miles in that direction and 75 miles in that direction. It would take you 3 hours to drive from one side clear to the other side. Now, what is this structure? We know it's not a volcano because we have not found any volcanic rocks from the last 200 million years. The magnetic field that has been recorded in the rocks from this area is very large, especially compared to other volcanoes, and the size itself. It is too large to be a volcano. That can only mean one thing. A gigantic meteorite coming from outer space and hitting here, ground zero at Chicxulub, killing off all the dinosaurs.
Over the past 65 million years, this huge crater has been filled with thousands of feet of sediment. The presence of iridium and the discovery of the crater is proof positive a cosmic missile hit the Earth at about the same time the dinosaurs disappeared. But how could a single meteor careering toward the Yucatan kill the most successful creatures that ever lived? The last day of the dinosaurs, T-10 and counting. An object capable of awesome destruction hurtles towards Earth. At speeds of 150,000 miles an hour, it plunges into the atmosphere. Moments before the collision, the dinosaurs would have seen the meteor's shimmering head and fiery tail. Traveling at such an incredible speed, the air in front of this gigantic meteor was unable to escape, and with a brilliant light came a deafening blast.
Imagine this 8-ball is 150 feet in diameter, the size of the meteor that made Meteor Crater in Arizona. If it struck the Earth at 150,000 miles an hour, it would have made a hole a mile wide and 600 feet deep. That's big enough to store 500,000 tractor trailers inside.
The devastation is so complete that for a radius of over 50 miles, everything was obliterated.
Now, imagine this bowling ball is 12 miles in diameter, the same size as the meteor that crashed into the Yucatan Peninsula. Traveling at 150,000 miles an hour, and that's fast enough to take us from here in Arizona to New York in 2 minutes. Imagine the devastation that this would have caused.
A meteor this big would have stood higher than Mount Everest.
The impact would have been hundreds of times bigger than this crater. The energy released, 100 million megatons, would be equivalent to 100 million hydrogen bombs, all going off at exactly the same time and same place.
At ground zero, the dinosaurs and all other living things are instantly annihilated. Within seconds, shock waves unleash a fireball of vaporized rock and molten debris into the atmosphere.
Well, the meteor plunges into the surface of the Earth, creating pressures equal to that of the Earth's core. That instantly vaporizes the meteorite and an equal volume of rock, which turns into white-hot gases that spew out in a gigantic plume, carrying trillions of droplets of white-hot molten silicate particles high into the sky over the Earth.
Two minutes after the impact, a mushroom cloud carrying particles of burning debris spreads over the land.
When these particles begin to rain into the Earth's atmosphere, the sky turns red. They create a radiant heat equal to that of a pizza oven. This goes on for hours. Now imagine the dinosaurs. Their hides would begin to smoke, burn. They would be literally roasted in their tracks, dying in agony as the heat sears the hides off of them.
The impact sparks a chain reaction beyond our worst nightmares. In rock samples he recovered from the KT boundary in northern Mexico, Dave Kring has found evidence of the burning debris.
These round objects are called tektites. These are once molten glassy beads of material that were thrown out by the Chicxulub impact crater. This impact event was so large that it threw this material clear across North America. And we now find it in a variety of KT boundary rocks like this sample from Arroyo El Membrao.
Green in color, this molten rock turned to glass as it fell to the ground. Under closer inspection, the teardrop shape of these deadly tektites can be clearly seen. But the dinosaurs weren't the only targets of these fiery glass balls. 10 minutes after impact, molten rain hits the ground, causing vegetation to spontaneously burst into flames.
To give you an idea what the dinosaurs went through when tektites heated the atmosphere to very high temperatures and caused wildfires, my friend Alfredo and I are going to give you a little demonstration. Okay, Alfredo. When the tektites and other debris went raining through the atmosphere, it heated it to incandescently high temperatures, and that caused global wildfires in the forests in North and South America.
Wildfires were only the beginning. Seismic shock waves trigger earthquakes. One hour after impact, tidal waves 400 feet high radiate from ground zero, crisscrossing the world's oceans. A wall of water as tall as a skyscraper hits the coast, submerging all of Mexico and most of the United States. Membral in northeast Mexico is hundreds of miles from ground zero, yet it still shows clear signs of the tidal wave.
65 million years ago, when the dinosaurs disappeared, this entire area was covered with a sea. When the Chicxulub impact event occurred 400 miles to the east, it threw out tektites, which then rained through the atmosphere and splashed down into the sea, forming this immense deposit of tektites beside me. Soon after the tektites splashed down, huge tidal waves came roaring across the Gulf of Mexico from the impact site and crashed onto the shoreline behind me. It then knocked down trees and ripped logs, and the backwash of the wave carried those logs and deposited them on top of the tektites and this rock above me.
Thousands of miles away, little did the dinosaurs know death for them would be slow and even more agonizingly painful. Their chances of survival were running out fast, as the next phase of the disaster was about to sweep the planet. In most of Central America, the impact of the meteor was devastating. Lush tropical forests teeming with life had disappeared beneath an ocean of water. Trees, once tall and mighty, were reduced to smoking stumps. For dinosaurs living on other continents, the disaster would now spark a chain reaction, igniting a series of lethal events. Proof of how globally fatal the impact really was has been recently discovered in the Gulf of Mexico. Research ships drilling thousands of feet deep off the Yucatan coast have recovered core samples dating back 65 million years. When the cores were analyzed, geologists found that they possessed a potentially fatal mixture of rock and gases.
The Chicxulub impact event hit two very important rock types. This is limestone and anhydrite. Locked within these rocks is a variety of toxic gases. For example, if I pour this liquid on one of these rocks, you can see the gases bubbling out from the rock. From the limestone, we would have produced carbon dioxide, which is a greenhouse warming gas. From the anhydrite, we would have produced sulfur dioxide.
Mixing these two with water vapor means big trouble. The impact would have thrown them into the atmosphere, creating a deadly cloud of doom.
Once in the atmosphere, the sulfur dioxide would have reacted with water to form sulfuric acid rain, which would have then rained out all over the world.
Ironically, if the meteor had hit anywhere else on Earth, the devastation would not have been nearly as severe, because the combination of minerals needed to create this deadly acid cloud is found on only 0.5% of the Earth's surface. The dinosaurs perished simply because the impact occurred in the wrong place at the wrong time. This discovery solved the mystery of their extinction on a global scale. On impact, the meteor exploded, hurling a cloud of sulfuric acid into the air. Within hours, the jet stream carried it around the globe. The cloud blocked the sunlight for over 3 years, causing temperatures to drop to near freezing. As the gas cloud cooled, it fell to Earth as acid rain. For 10 years after the impact, Earth was showered by burning droplets of sulfuric acid. Starved of light, plants died and the food chain collapsed. A nuclear winter descended on a previously tropical world. Then carbon dioxide began to fill the air in vast quantities. Temperatures escalated to sweltering levels. Large creatures like the dinosaurs had less fresh air to breathe, little clean water to drink, and fewer things to eat. In the agony of death, the Earth fell silent. For 5,000 years, the Earth was virtually barren. Then slowly, nature recovered, beginning a new chapter in the history of life. Although the reign of the dinosaurs was over, their extinction is not unique. Many meteors have hit the Earth. Very big objects traveling very fast through space, like the recent comet Hale-Bopp, can get pulled into our orbit and crash, causing unbelievable destruction. In fact, scientists predict that every 65 to 100 million years, Earth is struck by a giant meteor. So if the extinction of the dinosaurs happened 65 million years ago, the question is not, could it happen again, but when exactly is our time up?